Hey everybody, how's everybody doing? I'm back. It's been a while. Sorry, I've been busy with a lot of stuff, but I promise I will be more consistent and we're going to finish up this Power 25 series for you guys. So we have this nice curated playlist of the 25 most essential problems to ace these technical interviews. So anyway, without further ado, let's go ahead and get started back into the code. All right. So let's do this. So this problem is called number of islands. Very, very important problem. So we're given an n by n 2D grid map of 1's land and 0's water. We need to return the number of islands. Okay, so the definition of an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. So what does that mean? What do they mean by that? Right, so we're going to have a little walkthrough here. So when they mean the number of islands, what they kind of mean is all of the ones, kind of, if you would draw like a border around all of the ones that represent land, right? So this represents one island, right? So this is one island. If we draw sort of the land around this one, this is 2 islands. And if we draw the land around this one, this is going to be 3 islands, right? So we kind of know that going forward, right? We have 3 islands, and an island is basically things that are all surrounded by 1. So here we would output 1 because there's this huge chunk of ones, right? And in this one, we would output 3 because there's like kind of like my example, there was 4 ones here, there's 1, and then there's 2 ones, right? And then it's always good to look at the constraints. So we know that m is equal to the length of the grid, n is equal to the length of grid of I, and we know that the bounds are between 1 and 300, so that's good. Okay, so how are we going to solve this type of problem, right? So a very good sort of this is a very common type of problem, and you can kind of think of this as a graph. And what do I mean by that? What I mean by that is there is a 2D array of sort of these edges and vertices, and when you can kind of connect them together, right, intuitively. So these are like edges, and then these are vertices in a way. And how we solve this is we basically say, okay, well, what can I do and use recursion? How do I use recursion to solve this problem, right? So if we know that we encountered a 1, let's say that we're our pointer, we kind of do a double for loop to traverse, the array. So we kind of go all the way and kind of traverse all the indices. And what is our point of interest? Well, our point of interest is when we find this first island, right? So when we find this first one, we know, okay, well, this is the start of an island. We're going to want to explore further. So there's a very good search technique, and it's called depth first search. I'm going to make a video kind of explaining what depth first search is in depth. But what we can kind of do is say, okay, well, we know that there's a 1 here, and we're going to do a DFS. People call it DFS. And what DFS says is we're going to go check, in this case, in all 4 directions. So we're going to go to all of the 4 directions of this current node. So what does that mean? So we're at this 1, and we're going to go up. Okay, well, this is out of bounds of our array, so we're not going to explore that. So that's going to be an X. We're going to go left. Okay, well, that's out of bounds. We're not going to explore that. We're going to go down. Oh, hey, look, there's another kind of thing of 1, right? So there's another kind of plot of 1. So what we're going to do is we're going to kind of expand our border to encompass that. Now we're on this one. We're going to do the same exact thing, right? We're going to go up. Okay, well, up. What we can do for this algorithm is that you can kind of see here that if we do a depth first search and we go up again, we're going to find that 1, right? So before we recurse to the next one, we kind of want to mark this as visited. We want to mark this as, so we don't rediscover it, right? Or else we'll kind of be in an infinite loop. So what we can do is when we explore to the other one, we can just mark this as a 0. So we're going to go up, and okay, well, this one's already visited. There's a 0 here. Okay, so then we're going to go down. So what happens when we're going to go to the left. When we go to the left, this is out of bounds. Nothing's going to happen. We're going to go down. Oh, look at this. We found another 1. So we're going to mark this as a 0, and we're going to keep expanding our boundaries. So we're going to go up. Okay, well, this is a 0. We don't want to explore that, right? We only want to keep exploring if we find potential land, if we find more islands. We're going to go left. Okay, well, this is out of bounds. We're going to go down. Okay, well, this is a 0. That's water. We don't want to explore that. We're going to go right. Oh, look at this. There's going to be a 1 here. We're going to mark this as a 0, and we're going to expand our boundary. And we're going to, okay, so we're going to do the same thing. We're going to go up. Oh, look at this. When we go up, what's going to happen? Well, when we go up here, we're going to say, oh, okay, there's something up here. We're going to expand our bound. We're going to go up again, right? Because our depth first search, you can do it any way you want. I started going up at the beginning. We're going to keep going up. Right, and now look at this. So notice how I go up here. This is out of bounds. I go left. This has been already visited. I go right. This is water. And I go down, right? This has already been visited. So the thing about this, right, is that once this is already visited and these are all fine, we know that this recursion ends here, right? There's no other possible place you can go, so we can return 1. So this is a valid island. However, right? Remember, it's recursion, so we have to go back to the other recursive call. So we're going to go back here, right? Because we only traverse the up pointer of this island here. So when we go left, we go up. Now we have to go right, okay? Because we only traverse the up pointer, so now we go right. And look at this, we found another one here. We're going to do the same exact thing, right? We're going to go in 4 directions, up, left, right, and down. Okay, well, there's nothing else. And notice that this recursion ends and we return 1, and then that recursion turned 1, so this will just be a 1 here. And all of the other recursions, right, we're going to go all the way back, returning 1, 1, 1, 1. And look at this guy here. We didn't traverse its down pointer yet, right? We only went up, so we have to traverse the down pointer and encompass that one as well. And we can kind of see how all of these recursions are ending at the very end of this entire sort of chunk, right, this entire block. We're going to be returning a 1, right? And at the very end of everything, right, we want to reset the, well, actually, we're done, right? These can actually stay 0. So think of it as every time that you're exploring and branching on another island, you're kind of sinking the island. So these are all going to be 0s. So think of this array as all 0s now. Okay, so now we're going to recurse through our pointers. Remember, these are all 0s. So 0, 0, 0. We're here. We do the same exact thing, right? So we're going to go left. Well, left is 0. Up is out of bounds. We're going to do this. We're going to encompass this. We're going to go up. Left has already been visited, right? Because this is sunk as a 0. And we're going to go down. Okay, look, this has more to go. And now we do the same exact thing, right? We go up, that's already been visited. Right, that's out of bounds. Left, that's a 0. Nice. So that recursion ends, and all this recursion ends, and we'll return another 1. And then similarly, we kind of traverse through all of these. This is a 0, that's a 0, right? Because these have all been sunken. 0, 0, 0, 0. And the very last one, we find a 1, right? So we're going to go up in all directions. There's nothing to gain, but there's only this singular landmass, which is a 1, so that's going to be a 1. And at the very end of the day, we have 1, 1, and 1. And 1 plus 1 plus 1 is equal to 3. And that's how many islands we have. So that's the high level sort of overview of our explanation. We can kind of think of the time complexity real quick of this problem as you can kind of define however you want, but for DFS and graph problems, I like to say that it's O of V plus E. So you're thinking like, what is that? It's not O of N. Well, the thing is for a graph problem, right, is that if you have your vertices, you can think of a vertice as, either a 1 or a 0. Not only are you traversing through the number of vertices here, but you're also traversing through the number of edges. And what do I mean by edges? Every time that we branch off from a depth first search like this, that is defined as an edge, right? And you can kind of see how we're traversing through all of the vertices, and for every vertice, we're traversing through all of the edges of that vertice, right? So it would be O of V plus E. People say O of N, where N is the number of elements. That's fine too. I would say V plus E is a little bit of a tighter bound. And yeah, and then for space complexity, we're really not doing anything, right? We're not, I'll have a video separately on space complexity, but yeah, so that's about the high level overview, guys, and I will see you in the coding. All right, so moving on to the coding implementation here, we're going to get started, right? So kind of what we said in the high level walkthrough. So we're just going to say our num of islands. We're going to have this as a counter. We're going to set it equal to 0. And it's good to always do some bound checking. So if our grid is none, or the length of our grid, right, is equal to 0, well, I mean, we don't really have any items to explore, right? So we're going to return 0 because there's 0 islands in an empty grid. So now we're going to do exactly what we said, right? So we're going to loop through our array in a double for loop. So for I and j, and then for j in range length of our grid of I, right? Because it's m by n, right? We can't just naively say the first grid, it has to be both of them, right? Because this is the length of grid of 0, length of grid of 1. Okay, so if we encounter our point of interest, what is our point of interest? Well, that is when grid of I of j is equal to 1. We want to call our exploration. So our num of islands counter will just plus equal whatever we're going to make a helper method called explore islands, and we're going to pass in grid of I and j. So this helper method is going to keep exploring our islands, and it's going to increment our number of islands counter, right? And you can kind of see that more clearly here. And at the very end, we're going to kind of we're going to return a number of islands. So let's go on to the helper method, right? So we're doing def of explore islands, okay? We're passing in the instance, the grid, and then the 2 coordinates. Okay, so what are we going to do? This is our def first search. So every time we do recursion, we need a base case, right? So if we sort of explore and we say, okay, well, we need a way to kind of see if the coordinate is invalid or not. Remember how I was checking the bounds and some were good and some weren't? Well, self.invalid coordinates, we'll just call it that, of grid of I and j. So if it's an invalid point or intersection, well, we're just going to return 0, right? Because we don't want to explore it. So let's go ahead and do that method real quick. So invalid coordinates. Okay, it's going to take in the instance. It's going to take in the grid. It's going to take in I and j. So what do I mean by this? So we're just going to return, how do we check if things are out of bounds? So if I is less than 0, that's bad. If I is greater or equal to the length of our grid, that's bad, right? Or if j is less than 0, so we're just bounds checking here, or j is greater than equal the length of grid of I, right? So if j, or there's one last thing, or we encounter water, that's invalid, right? We don't want to keep exploring if we encounter water. So if grid of I is equal to 0. So we're going to return this. So that's basically saying if the coordinates are invalid or not. Okay, well, if they are valid, we're going to mark that. We're basically going to, this is called, like, we can say sinking the land or sinking the island. We're going to set this equal to 0. Okay, and we're going to explore always. So we're going to call self.explore island. We're doing our DFS now. So we're going to do self.explore islands, and we're going to pass in the grid. We're going to pass in I minus 1. We're going to pass in j. Okay, and this is top, right? We're going up to the top, and we do this 4 times for our sort of our coordinates, right? So we're going top. Let's see. And we are going to go, okay, so we just need to kind of change the method to go in whatever direction we want, right? So we're going to go top. Let's just go for arbitrarily top, bottom, left, and right. So we're going to go top, right, bottom, left is going to be I minus 1, and right is going to be I plus 1. And then at the very end, once this goes, we're going to return 1. Cool. So that should be fine. Let's see what we get. Nice, and outputted as expected, we get our value, and let's go ahead and submit it and see what happens. Let's see, and right there, guys, we submitted. We have a great algorithm, very, very important for technical interviews. This is probably the most important question, just knowing DFS and traversing through these. These are called matrices or 2D arrays. Very important to know kind of this concept of DFS. Anyways, thank you guys so much for watching. I will be way more consistent with my videos. I'm kind of motivated to get on YouTube again, and have a great day.